This is question 44 from the GATE 2021 EC paper, where the transistor M1 has the following mu and Cox and W by L, right? And the channel length modification coefficient is asked to be ignored. If the gate source voltage VGS is 1 volt to keep the transistor at the edge of saturation, then what is the threshold voltage rounded off to 1 decimal place? Underneath the question, you will find the title of the NPTEL course or video relevant to this topic. Let us proceed with the solution of this problem. We are given that W by L is equal to 10 and that this RD value is 20K and VDD is 3 volt. The idea is that the transistor is having a K of mu and Cox W by L, which is 1 milliamp per volt square. So at VGS is equal to 1 volt, we have that VDS is VGS minus VTN. This is the edge of saturation condition, right? So VDS is equal to 1 minus VTN. Now VDS is also equal to VDD minus IR, right? So 1 minus VTN is equal to, so VDD is 3 volt and RD is 20K, right? R is the resistance here. So I flows here, so this is IR. So therefore we have the voltage here as VDD minus IR, right? So the value of VDS as two expressions are 1 minus VTN and 3 minus I into 20K, right? But I, of course, is equal to, since we are in the saturation region, mu and Cox W by L, that is K by 2 into VGS minus VTN the whole square, right? So this is the value of I. Substituting the value of I over here, we get 3 minus mu and Cox W by L into 1 minus VGS minus 1 minus VTN the whole square into 20K, right? And you can pause the video at this point to see the working out of the steps, but essentially we have to solve for VTN in this equation, and we will get a quadratic equation in terms of VTN here, right, which has the following roots as 21 plus or minus 11 by 20. Now VTN we need as less than 1, so therefore we are going to ignore the 21 plus 11 as an invalid solution, and what we get is 10 by 20, this is 21 minus 11 by 20, which is equal to 0.5. Thus the correct answer is 0.5 volts.